I've wanted to build a hand crank generator for a while now, and since I just bought my new 3D printer, the Bambu Labs P1S, I thought I'd try as a first project. Here's how it went. The goal of this project was to make a hand crank generator that could charge my cell phone, basically at 5 volts, around 1 amp, and do it continuously so that if there was a power outage or I just wanted to power any of my projects in the future without hooking it up to a power supply, I could. To start off, I jumped into Autodesk Fusion and I started modeling what I thought would be a good idea. I then thought through what parts I would need to buy that I couldn't 3D print, such as the magnets. I knew I'd need some bearings, and I knew I'd need some circuitry, some diodes to rectify it from AC to DC. After all the parts came in, I started taking measurements with the caliper and finished designing the rotor, stator, spline shaft, and other essential parts to get the base of it working. The last part that I had come in was the copper wire so that I could wind my coils. Deciding how I wanted the coils arranged was probably the hardest part of the project because I had to think through A, how many coils did I want, B, did I want it to be a 3-phase system, or how did I want this to set up. So what I ended up doing was this. I had 12 coils and I hooked 2 of them up in series and then 2 in parallel. So it really was, it increased the voltage and amperage possibilities because I had very thin wire. I believe it was 28 gauge. So here's the schematics for how I did it. The dots on the inside are the inner coil connections, and the lines to the outside of the circles, the outside of the coil connections. And then you can see coils 1, 2, and 3 are meeting in the middle for a Y connection. If I had to do this again, I would change the soldering to a PCB board of some sort so that it wasn't so messy. I had a lot of wires hanging loose in there. This led to part of the problems with this design. Now that I had the coils finally on the stator and I had magnets put in opposite of each other, so one magnet had the north side facing up, the next magnet was south side facing up, and you just keep going. Once I had that done and I had the first 3D prints done, I was ready to assemble them in the body and test for voltage. And yeah, the first voltage was pretty low. I think it was around 0.4 volts with just my hand spinning it on one rotor, so it wasn't 2 rotors of magnets It was just one, but it was promising. It showed voltage. It worked. Then I added the second rotor and a simple handle so that I could grip the shaft easier, and now I was able to get a lot more voltage. Then I threw on a leveraged handle so that I could easily crank the wheel. It had no gear ratios yet, but I was able to accomplish a couple volts. Next, I had to design the gear ratio for the wheel so that I could crank efficiently and get enough voltage out. So what I did was I did look up a gear ratio for how much strength would be required to crank it at a certain gear ratio, and I came out with, I think it was an 11-to-1 gear ratio is what I did. The next step was to get the electronics working, so I had to design the diode rectifier. So I connected the diodes in the correct formation, and then I soldered them to some perf board, and then I made the connections in the following schematic. Now when I hooked up to it and I put the wheel on it, this is what I got. That's right, we were able to get up to about 8 to 9 volts on this, which was nice. I was feeling pretty confident about that. Then I threw it on the oscilloscope to see what the waveform looked like, and as you can see, without anything to smooth it out, it's pretty bumpy. There was actually, I think, a 1.4 volt peak to peak, if you want to think of it that way. So then I threw capacitors in to smooth it out, and we got it to under what the average is for like a phone charger, which is around 1 to 200 milli, or yeah, 1 to 200 millivolts. The next step was to add a buck converter to keep it at 5 volts so that we didn't over voltage and damage the charger. So I added a buck converter, and this is where things started getting complicated, because under load, this 11-to-1 ginormous gear ratio started wobbling side to side pretty bad. So I ended up having to add multiple different designs with multiple different setups, and I could just never get it to stay aligned correctly, and it would slip off to the sides too easily. This was the start to the downfall. The more I added on the load side, the harder it was to crank, the more torque it required, which I knew was going to happen. But I think the small wheel was just too small and the gears were too big. They didn't align the best. Even though I did use the herringbone 3D gear design, which is self-aligning and helps to keep the weak 3D gears together, it still wasn't enough to keep it all aligned. In the end, I was just happy that I had something that was producing voltage. It seemed too sloppy, and I spent too much time on trying to fix it that I just wanted to scrap the whole thing and start fresh, because I had so many ideas. Overall, I was really happy with this project. I learned a lot. I learned how to 3D print. I learned how to use Bambu Labs or Bambu Studio to export my prints. If you would like any of these designs, I'm going to have a link in my description to the Patreon page where I'm going to have all my 3D print files. I would like to continue this project and make a better version in the future, but for now, I'd like to jump on to some other ideas that I have. If you enjoyed, please subscribe, like, and thanks for watching. See you in the next one.